Hello, AC Science students. We're looking here today at Thursday, December 17th. The main goal today was the Tectonic Investigation 2. That was due today. So in class, we went through and we talked about all the important parts. And again, kind of as you work through, the most important part is to follow the directions. It's all about getting the information and kind of figuring out as we go. It's not necessarily about the right answers in the document. But some reminders in here. Step one is all about opening the GIS, which is pretty short. Step two gets into identifying and tracing these boundaries. And basically what they have you doing in here is tracing. You can actually draw in the GIS where those boundaries are, and you just follow the line of earthquakes is basically the point. So they can work through with some of that stuff. There is an exporting the map or taking a screenshot. So make sure you've got that in there before questions 1 and 2, or before question number 1. So make sure there should be a screenshot of your map in there beforehand. Get that updated as you work through. The next one kind of takes you through and just identifies the different plates next to North America. So here's the North American plate, of course, right? There's a Pacific plate. We have the Eurasian plate, the African plate down to the south of us. If I turn on the earthquakes again here. We actually have 3 little plates, 2 little plates and a big one, I guess. There's the Cocos plate, the Caribbean plate, and then of course the South American plate. So we're kind of looking through and finding those and making sure we can identify where those things are at. The next part of the instructions take you into the Pacific Northwest. So step 4 is to revisit the Western Plate boundary and investigate volcano locations, and starting to get some of those in there. So if we turn volcanoes on, and I'm going to go look in the Pacific Northwest. And so we're looking here. This is the Juan de Fuca plate. It's a little tiny plate, and you can see the outline here with the earthquakes. And then the other edge of the plate is actually right along here. And I can tell because it follows this line of volcanoes. Remember, earthquakes happen on a plate boundary. Volcanoes make the line just next to the plate boundary. So we can kind of tell where that is. Okay. There is a tracing and map export that needs to happen here. This goes with questions 5 and 6. So that outlining and describing the design of the layout, identifying where the Juan de Fuca plate is, that is a thing that needs to be in your sheet in there with kind of questions 5 and 6 in that area. Okay. The next section takes you through identifying the types of plate boundaries. There's 3 main kinds: divergent boundary, a convergent boundary, and a transform boundary. So divergent boundary, the plates move apart. Convergent, they move together. And transform, they move next to each other. So if I turn on plate motion and go back to North America. So if I look here, this is a divergent boundary. The North American plate and the Eurasian plate are separating apart. And again, some of there is that asthenosphere on the bottom, which is kind of putty-like rocks. And then the lithosphere is the rocks that we know, the plates are rocks that we know. And as those things pull apart, as those 2 plates pull apart, some of that asthenosphere pushes up through and cools off and turns into regular old rocks, things like basalt typically. There's also convergent boundaries, like this one over here. This is a convergent boundary where the 2 plates are moving together, and as that happens, one plate slips underneath the other one. Typically, an oceanic plate will sink underneath a continental plate, but that's kind of what's happening there. You can see that it's going to melt then and kind of turn back into that asthenosphere eventually. The other kind of type of boundary here is the transform boundary. And this one, the plates just move past each other. That chunk of lithosphere, the crust, the rocks that we know, just kind of sliding past each other. And of course, the famous one over there is the San Andreas Fault. That's a big transform boundary. Okay. As I revisit the Pacific Northwest and we look at that motion of that Juan de Fuca plate, and Juan de Fuca is kind of right in here. So notice those 2 arrows are pointed the same direction. So Juan de Fuca is moving kind of away from the Pacific plate and then towards the North American plate. So that is a convergent boundary with the North American plate right there, where the Juan de Fuca plate is actually slipping underneath the North American plate. And then, of course, a divergent boundary over here with the Pacific plate. So kind of working through those things. The last section deals with types of lithosphere. And there's two main kinds, oceanic and continental. And we can start to see the line, sort of, this is continental. So that will have rocks, lots of different kinds of rocks, where maybe some metamorphic rocks have been lifted up, or sedimentary rocks that have formed and been lifted up or uncovered from the ocean. But oceanic crust is most typically basalt, or some version of something close to basalt. But you can see the kind of line where that happens. And of course, this is the Pacific plate is mostly oceanic crust as well. But the North American plate is interesting because some of it's continental crust and some of it is oceanic lithosphere. Okay. So make sure you've got that all filled in and turned in. Again, the understanding is the important part. If you have questions on it, please make sure you come and talk to me. Talking to me about it is going to be the best thing for you. Kind of finishing up, looking ahead. Tomorrow, Friday, we'll be looking at Tectonic Investigation 3. And on Monday, that Tectonic Investigation 3 is due. So we'll go over that investigation together and make sure we got all the right stuff in there. And then we will be looking at a Tectonic Investigations 1 through 3, a quiz on those, what we've learned from those first 3 investigations. So we'll be ready for that next week. As always, if you have questions about anything, please let me know. Otherwise, have a great day, folks.